Hello friends, I am Mrs. Raut Vaishali Sanjay, Assistant Professor, KVN Naik College, Nasik. Today we shall be discussing about paper chromatography. Definition: paper chromatography is a method of separating the mixtures by using moving solvent on the filter paper. A drop of mixture, or that is solution, is placed near one end of the paper and then dried. The end of the paper nearest the spot is then dipped into the solvent without submerging the spot itself. Principle: the principle involved here can be partition chromatography or adsorption chromatography. Partition chromatography because the substances are partitioned or distributed between liquid phases. The two phases are water adsorb on the cellulose fibers in the paper, and the other phase is a mobile phase which passes through the paper. When the mobile phase moves, the separation of the mixture takes place. The compounds in the mixture separate themselves depending upon their affinity towards stationary and mobile phases. In the adsorption chromatography, the mobile phase is a solvent, and the stationary phase is the paper surface itself. Steps in paper chromatography. Step 1. A horizontal line is drawn near one end of the paper. Step 2. The sample that need to be separated is placed as a small drop or a line on the paper using capillary. Then the drop is labeled with the pencil or with an alphabet or a number which helps it to identify the compound later. The drop are then soaked on the paper and dried. Step 3. The paper is then placed on the sealed container with a shallow layer of suitable solvent. The solvent level must be lower than the pencil line or a drop on it. The container need to be covered to stop the solvent to evaporate. Step 4. The solvent rises up in the paper, taking each component of the sample with it. The component travel with the solvent depend upon few things: the polarity of the sample molecule and the attraction between the sample molecule and the solvent or solvent mixture. Step 5. When the solvent rises near the end of the paper, then the paper should be taken out from the sealed container and air dried. Next important step is identification of components of the mixture. The methods of identification are physical methods and chemical methods. Physical method: the component, if they are colored, then they can be easily identified with naked eyes. The paper with the separated bands of the component are observed under UV light if they are not colored. In the chemical method, the mixture is spread with various chemicals to identify the solute molecules. Like ninhydrin is spread for amino acid, hydrogen sulfide is spread for group 2 elements. Now, to make the technique more scientific, rather than just by interpretation by sight, the retention value or the RF value was applied in chromatography. A particular compound will travel same distance along a stationary phase by a specific solvent or a solvent mixture, given that other experimental conditions are kept constant. Every compound have a specific RF value for every specific solvent and a solvent concentration. RF values come very handy for identification because one can compare RF values of unknown sample or its constituents with RF values of the known compound. Now, how to calculate the RF value? The RF value is defined as the ratio of distance moved by the solute, that is by the dye or a pigment, under the test, and then the distance moved by the solvent, also known as solvent front, along the paper, where both the distances are measured from the common origin or application baseline. That is point where the sample is initially spotted on the paper. It is calculated as distance from a baseline traveled by solute divided by distance from a baseline traveled by the solvent. The graph of RF values for few solvents, few molecules are shown here. Just substance A, B, C, D, E, F. You can see it is different for different substances. Types of paper chromatography. It is classified as ascending chromatography. As the name indicates, in the chromatogram ascends, the development of paper occur due to the solvent movement or upward travel on the paper. The solvent reservoir is at the bottom of the beaker. The paper tip with the sample spot just dips into the solvent at the bottom so that the spots will remain well above the solvent. Descending chromatography. Here the development of the paper occurs due to solvent travel downwards on the paper. The solvent reservoir is at the top and the movement of the solvent is assisted by gravity besides the capillary action. Types of chromatography. Two-dimensional chromatography also exists. In this mode, the samples are spotted to the one corner of the rectangular paper and allowed to for the first development. Then the paper is again immersed in the mobile phase at the right angle to the previous development of the second chromatogram. Radial mode. Here the solvent moves from the center towards the periphery of the circular chromatographic paper. The entire system is kept in a covered petri dish for the development of chromatogram. The wick at the center of the paper dips into mobile phase in a petri dish, by which the solvent drains on the paper and moves the sample radially to form sample spots of the different compounds as concentric rings. Applications. There are some applications and uses of the chromatography in different fields are discussed below. Separation of amino acids to check the purity of pharmaceuticals, to inspect cosmetics, to detect adulterants, to detect contaminants in the drink and food, to examine the reaction mixtures in the biochemical laboratories, to determine dopants and drugs in humans and animals. There are many more applications which we cannot discuss in this video. Thank you.